only mode.
Hello everyone, and welcome to the webinar. This is Sydney, and today's webinar will actually be continuing from last week's, where we talked about the automatic feature recognition and machining. And last week we talked about pocket recognition and chamfer recognition. This week we're going to deal with hole recognition and drill recognition. This is actually the second part of the webinar. Next week we'll have the third part, where we'll be talking about our newest option of Hole Wizard, SolidWorks Hole Wizard recognition inside SolidCAM, together with machining process. Okay, so let's start with this week's webinar. And as I said, this week we'll be talking about drill recognition and hole recognition. Okay. Now, what exactly is drill recognition? Well, drill recognition is a one-tool operation. In any case, we're always using one tool. Okay, that's it. Just one tool. Now, however, what drill recognition does, it actually picks out the geometries from the entire part of all the holes, or a specific set of holes on different levels to be machined out. This is actually very helpful, excuse me, this is actually very helpful for when doing spot drill operations, where you want to take all the holes and put a spot drill on each one of those holes, no matter what level they're in. But more than just a plain old spot hole, you can even do a spot hole that the diameter of this spot will get it to the exact diameter of the hole itself. Let's see exactly how this works. Okay, I'm just going to switch over to the other screen. And we'll start off with this part as shown over here. Now, last week I actually did start working on this part when we did our pocket recognition and chamfer recognition on this part itself. But as you can see, there are a lot of different size holes over here. You can see there are these holes over here on different levels, different sizes. We even have this big hole over here as well. So I'm going to start my operation of recognition of what we call drill recognition. Now, if you take a look over here, this looks exactly like any other drilling operation. So as far as the tool goes, that is and the technology, that's completely up to the user himself, according to the whatever the programmer wants to use. But let's see now how the geometry works. When we choose our geometry in this case, when we create our geometry, right now, if I were to click on Find Holes, it'll find every single hole that's on this part itself. As you can see, these holes here, this shape over here, those shapes over there. You can see it broken up into different shapes, as well as this really large hole. Now, actually, however, I want to limit to what diameter hole I'm working on. So I want to have another option over here, and I do have another option here called hole diameter. In the hole diameter option, I can actually filter out the holes that I don't want. I can say I want to work from a specific size hole up until a specific size hole. Now, if I want to do all the holes except for really large holes, so I'll leave from at 0, and then I'll just go into 2, and I'll highlight the 2 area. All I have to do is go into the onto the part itself, and I can just click on what's the largest hole I want to deal with. Say this is the largest diameter over here I want to deal with, and it's going to put that value in over there. If I want something smaller, I can even write something smaller. Let's say 19. Let's say I don't want to do those over there. All I have to do now is click on Find Holes. And again, it went through and did a scan of the part, and it only included those holes that fell within those two values over here, between 0 and 19. You'll note the large hole was not chosen anymore, as well as this over here. Now, that's all I have to do to pick up my geometry. Now, if you take a look, by the way, at the shape, if I right-click on it, you can see Show Hole. Show Hole shows me the actual shape of that particular group of holes. If I were to go to Shape 2, you can see that shape changes as well as in group Shape 3. Okay, I'm just going to accept exactly what I have here now. And the rest, we'll take a look how we deal with it. The tool I choose my own tool. Okay, so I decided I'm going to use a spot drill. And I'm going to use a 20 millimeter spot drill. No problem with that. Now, I'll select that. Now we have our levels. Now, what I want to actually do is I want to have my chamfer, my spot drill, go all the way down so that the diameter of the spot at the different points reaches the diameter of the hole itself. So we have the following option. I'll go to Depth Edit, and I'm going to go immediately to the very bottom. You can see right now, first of all, the very top one over here is highlighted. If I click on Auto Chamfer Spot Drill and apply it at this point, it's only going to do it for the top one. If I wanted to do it for all of them, I'll click the option, like I said, Auto Chamfer Spot Drill, and check for all, and then apply it. This way, it applied it to all of the holes on the part itself. Now, in addition to that, we have our chamfer depth. If I set my depth, chamfer depth, in other words, beyond the diameter of the hole to 0, it'll go to exactly that diameter of the hole itself. Now, again, since I want this for all of them, not just for the very first one, I'll click on All and Apply. That's it. The rest is just like any other drilling operation. You can set my shortest distance, whichever way I want to work. Let's just do Save and Calculate and run my simulation. Solid Verify. And as you can see, all right, I had one little problem over there, no problem at all. And that's because I had a hole over here, and my end mill, my spot drill was a little bit too large for that. But that's what we have our simulation for, so we can see. But you can see in all the other areas, all of the holes have a spot drill on it, exactly to the diameter of that particular hole. Okay, let's continue now. And next, I'd like to work with a single drill to a specific diameter. Okay, so the way we continue is we'll just do Save and Copy. And now I'm going to choose a new geometry. Now in this geometry, say I want to create a drilled hole for this particular size hole over there. So when I go into my hole diameter, I'll click on From, highlight the From area, and click on the diameter of that particular hole. Note what happens. It picks out 6.8, and the 2 is also at 6.8. So in other words, at this point, it'll only choose the holes that are 6.8 in diameter. Now when I click on Find Holes, you'll note that I have two groups. My first group is on top over here, and my second group is on a different level. So in one operation, I'm actually going to be drilling out those two groups on different levels, different upper levels, different lower levels. All of that is being done in one operation. I'll accept that. Again, just choosing the tool, and I'll create my tool, my regular drill. Now my diameter, if I highlight the diameter, I can write in here if I want 6.8, or just highlight this area and just click. Let me just zoom in a little bit. Click on the edge of the hole itself, and the value will go in there automatically. select. Levels, I don't have to deal with the levels at all. The levels are automatically taken care of. Let me show you why. Because the default values over here is as follows. You can see in the first group, my default upper level is -10. It knows that. In my second group, my upper level is at 0. So it knows all of this. In my first group, my drill depth is 19, just over 19. And my second one is just over almost 22 millimeters. So you can see all of this is chosen automatically, picked up automatically from the part itself. All I have to do now is go into my technology, choose whatever drilling technology I want to use. Let's say I want to do a pec drill. No problem. Just take care of my data. Step down every 5 millimeters, for example. And now let's take a look at my simulation. And the way I'm going to do my simulation right now, let's take a look at it from the side. And I'm going to change it to wireframe so we can actually see through the part itself. Let's do it without the solid verify. And let's take a look in this area over here. You can see that the tool would automatically go down to just above that hole itself. And then start pec drilling into that exactly to where it has to go. Going over now to its next hole. Let's finish that particular group. Actually, let me do it again. Second hole, third hole. Now you can see the next hole over here, which is a different level, started from the 0 level and goes all the way down to the bottom of that particular hole. The same thing on the side over here. Sorry. There we go, zoom in over here. You can see that as well as it goes down exactly to that depth that it has to go down to. Okay, now if I want to continue, that's not a problem at all. Again, it's not a problem. All I have to do in this particular case, again, do save and copy, sorry. And again, choose a new geometry. This time, I'm going to have my hole diameter from, let's choose, say, this hole over here, 6.6. Find the holes. We have, again, two different groups, this one over here and this one over here, and we'll do the exact same thing that we did in our last one. Tools, create a new tool. I'm just going to copy the old one and just change the values. So I'll do copy, and the new tool will have 6.6 diameter drill. Will be a 6.6 diameter drill. The rest, I'm just going to leave exactly the way it was. Save and calculate, run my simulation, and it'll work on those holes as well. And I can go on and on with this part. In other words, but you notice it's a single tool operation, but it drilled on multiple levels in this particular case to multiple depths. If I would have to do this separately, I have to pick out the geometries separately for each one of them, pick my upper level, pick my lower level for each one of those individually, and then do the operation again. Over here you can see as far as the depth, it picks out all of them in one operation. Okay, let me actually load now a different part. Okay, we'll go into, let me see what part I'm going to load. I'm going to load this part over here. Okay, now this part is a little more complex, as you can all see. In this particular case, if I were to machine this and drill this out, if I were to do this individually, we have holes all over the place, all different levels. Okay, now besides that, I also have multi-sided. In other words, I have to drill out, and even though this machine is a five-axis indexial machine, I would still have to create also home positions for each one of the sides over here, as well as this side over here, even though it's on a multi-axis machine. The home position I still have to create as a different position. Same MAC, different position. Now I'm just going to start with one slide over here, showing how we would start working with the option of drill recognition. Okay? Again, we'll go into recognition, drill recognition, and we'll do the exact same thing we did last time. My hole diameter, I'm going to have my maximum hole, excuse me, let's pick out this one over there, 12 millimeters. That's the maximum hole I want to deal with at this point. Okay? Find holes. You can see all of the different holes were picked out that fell within that limit, between 0 and 12 millimeters. Okay. The tool, I'm going to use a spot drill. In this particular case, the spot drill I'm going to use, let's use a 16 millimeter spot drill. No problem over there. My levels will go into depth edit, just like last time. And I'm going to do the following. First of all, again, auto chamfer. All. Apply. Now, as far as the chamfer depth, this time I'm going to give it a chamfer depth of 0.5 millimeters and apply that to all of them as well. Let's see what the result is. Run my simulation. We'll use Solid Verify. Excuse me. And you can see all of the holes were drilled out with the spot drill exactly according to the depth that they were supposed to go to. Well, actually, let me actually start my next operation and then pick out a specific size hole. This time I want to work on, say I want to work on this particular hole over there. So I'll have my hole diameter. I'll click on that diameter, I'll put 12 millimeters in there and find all the holes. Note it found all the holes that are 12 millimeters in diameter. As far as the tool goes, I'm just going to create a 12 millimeter drill. Technology, if I want to do a pec drill, not a problem. Step down every 5 millimeters or whatever, 6 millimeters. I'm going to run my simulation again using Solid Verify. And what you'll notice as follows. If I zoom into the holes itself, you can actually see the chamfer that's left from the spot drill. Because I said I wanted to have a 0.5 millimeter chamfer depth, and it did that for those drills as well. Now, I can continue on this entire part. Of course, it'll take me quite a while to do all of this in drill recognition. And of course, if I go into my coordinate system manager, I would have to create a home position, not just for the very top, but a home position for every single one of those sides. Well, how else can I do this? Actually, I'm going to put this part on the side for now, and I'm actually going to start with my next part. And what I want to start talking about before I actually start the part is the next subject called automatic hole recognition and machining. Okay. Now, what exactly is automatic hole recognition and machining? Well, what it does is it automatically scans the entire part. And what it does is it classifies every single shape and group of holes on the part itself. What do I mean by shapes? You'll see that in a few moments. It also selects and or creates the tools that are needed for each of one of those operations. When does it select? If the tool already exists in your tool, but in your tool table, it will not create a new tool. It will use the one that's there. And it also knows how to automatically build the proper machining technologies that you want to use for doing that hole. Sometimes you need to mill out certain areas. Sometimes it's enough that you do a drill in those areas. All of this is done automatically. In other words, it's going to create the technologies for you without you doing anything. And an important part of this is that it supports all work position orientations. So let's see exactly how this works. Let's see the action, as I said, in action itself. Okay, so what I'm going to do is I'm going to load another part, and I'm going to go back to the very first part that we had on our screen before. We'll open up that part. And let me get rid of what I did here before. So I'm going to get rid of these drilling operations that I started before. We'll delete those. Okay? Deleted all of those. And in fact, I'm going to clean everything. No geometries, no extra tools, everything I'm going to clean. So I'll just go over, right-click over here, Clean CAM Part. I will remove everything that's not being used, any G-codes, any kind of updated stock. Everything is going to be removed, including unused tools. Everything was removed. Okay. Now let's do what I call the recognition of the part itself. To do so, we do the following. If we go to Operations and right-click on it, we have here what we call Hole Recognition and Technologies. Now, the default, when you get the program the first time you open this up, what you'll see here is as follows. You'll see this folder here, this option over here called SHR, System Hole Recognition. And that's it. These two that you see here are ones that I've created afterwards, and I'll show you how I create them also as well. Now, there's another one here called Part Hole Recognition. This is available the moment I create a hole recognition for this particular part. It automatically creates a database for this part individually. So basically, this is a list of different databases that I can use. So let's start with what the system gives us. Okay? If I were to open up the part, just click on it, what's going to happen now, it's actually recognizing the entire part. In other words, it scans the entire part, recognizes every single hole that's on the part of here, according to different shapes, as shown over here. Okay. Now, if I click, all I have to do now is just go across from left to right. I'm going to do this slowly first to try to explain slightly what each one of these does. For instance, the second one actually breaks it up into different segments. For example, this particular shape is just a regular drilled hole. Okay? Whereas this shape, as you can see at the bottom, it shows you that it's a chamfered hole and a drill hole. It has a chamfer on top. It's built with two different segments, a drill and a chamfer. The next group, next shape, you can see it has a flat cylinder and a drill. So that's how it actually broken up into different shapes. If I go on top over here, I can actually show you this shape. You can see how exactly this is broken up, the flat cylinder and the drill itself. Same thing over here, the chamfer and the drill. All of this is picked out automatically from the part. Let's close this picture. I don't want to see it anymore. And we just continue on down the line. The next shows you what it is going to work on. You'll note that's going to work on these features over here. It has one feature set where it's going to do everything that it has from this position. Now, I said that this particular machine only has 3 axes on it. And I've only created one home position. So therefore, if you'll note at the very bottom, it shows us that there are incompatible features, as shown over here. Okay? Because those are counterboard from the opposite side. So it's not going to work on that. The next just decides what technology has to be used. And last one builds the actual operations. Okay, I talked a lot, but actually all I really did just now was just click 1 through 5 and we have now all our operations created. Now, if we take a look at the list of operations over here, except for the first three, which I had from my previously before I started the recognition, you'll note that I have a total of 34 less 3. So in those few clicks, I created 31 different operations. The technology of how I do everything was done automatically inside the automatic call recognition and machining based on the database that was done over there. Now, what exactly is the database? Let me go back into whole recognition technology. It will go into the database itself. When I click on the option of starting my whole recognition, it automatically uses a specific database. What's the database? If you take a look on top over here, we have here the technology database. This database now is specifically for this part. It took it originally from the SHR, from the system, and put it into the part itself. All the database does, if I were to open up, it shows you exactly what it's going to do. Now, again, you do not have to deal with this. I just want to show you exactly behind the scenes what's going on. It's actually taking whatever it recognized as a drill and does the following. It does a drilling operation. However, how does it know to do a drilling operation or peck drilling? It starts by looking at a drill, and it must fit this criteria. Okay? If it does not fit any of this criteria as shown with the values down here, then it automatically goes to the next one. If it sees that it's deeper than a regular drilling operation should handle, it'll go to the peck drilling. Now, if the peck drilling is still even deeper than that, just a really deep drilling hole, then it'll go to the next one where it has a deep drilling option as well. If it's a too large of a diameter hole, it'll then go and show and step down to the two-step drilling where it'll have different diameters going into that drill. Smaller diameter, then a larger diameter, and so on and so forth. Now, each one of these can be edited as well. If I were to say, for example, right-click on the drilling, I can go in there and edit, and I can have my technologies over here edited as well. This is a ready machining process, so just giving you a heads up. However, if you've changed anything over here, and you want to keep this as your permanent database, all you have to do is click on Save As, and you can create a new database. Let's call this the stainless. So I can create a database for a specific type of material. Now save it. Now when I go in to my operations and open up whole recognition, you can see I have one here called stainless, and use that one, which will have all the changes I may have made. Okay. Now, I've mentioned all of that. Let's actually take now another part. There are two more parts I'd like to show you. First, let's take a look at this particular part over here. It's a typical electronic housing part. Note what we have here. We have here holes on top. We also have here holes from different positions. Okay? Now, if I go into my coordinate system manager, now this is a 3-axis machine, again, just like before. If I go into my coordinate system manager, we only have one home position. So you'll know from the previous part that these holes will be incompatible because I only have one position. However, let's see what happens if I create more positions, more MAC positions, okay? I'm going to, now, since like I said, since this is a 3-axis machine, each position is a different MAC. So I'm going to add a new one. Let's first start with this side over there. Okay? We'll accept that. Let's create another home position. we'll walk over now to this side over here. And as you can see now, we have 3 different Mac positions over here. And we'll do one more for this side over here. Okay, we'll accept that. So basically what we have here, we have our first position, second position, third one, and fourth one. Okay, exactly the way I've created it. So now I have 4 different Mac positions. Now let's see what happens when I create my hole recognition. So we'll go into hole recognition, and we'll use the SHR. And now I'm just going to go through the motions. Click number 1, click number 2, click number 3. Note, there's nothing that's incompatible. However, you should note that we have here 4 feature sets. The one that's highlighted is the one that's the current feature set. If I were to right click on this one, then this one will be the current feature set. The building of the operations is according to the feature set that's active. So let's do it according to feature set 1. Build the technology. Build the operations. Sorry, I forgot to do one thing at the very beginning. My mistake. Forgot to recognize. Okay. 1, 2, feature set 1. Created the first one. If I want to do it on the other feature sets as well before I leave over here, click over here, right click on feature set and make that one now as current. Again, just step through these. I can go now back, do feature set 3. And I can go back one more time and do feature set 4. Now if I go out, you can see we have the operations for all of the different holes. Not only do we have the operations, it can recognize every single feature in here, including tapped holes. If I go into my tool list, you can see it automatically recognizes the taps and put those taps in there as well. If I were to run my simulation on all of the operations over here, using Solid Verify, you can see that everything was picked up on the part and done exactly the way it was supposed to be done. Now, I'm going to load one more part. And I'm sure you can guess already which part that's going to be. Let's go back to this part that I started off with over here. Okay, I'm going to get rid of these 2 tools that I used over here. These 2 operations, I'll delete those. Okay, again, I want to clean the entire CAM part. So I'll select those and clean it up. Now note, in this particular case, if I go into my Coordinate System Manager, remember I only have one home position. Now in this particular case, since it's a 5-axis machine, as far as my Mac positions, I only need one Mac, okay? Because it's being held in one fixture. I need, however, different positions for each indexial side. I'm not going to create them. Let's see what happens. Okay? Now, I'm going to go back into my operations, go into the option of hole recognition and technologies. Excuse me. Again, this is a larger part, so a lot more holes that it has to recognize. We just click on recognize the holes themselves. As you can see, they're all now being recognized. And we'll go through the motions just like I did before. Now to building the technologies. Remember, I only had one position created on the part itself. All the operations now are being created. And I'm done. Note what happened here. Less the first two operations that I had over there, we have 144. So in those few clicks, I created 142 operations. Okay? But not only that, let's take a look at my coordinate system manager. We'll open that up. You see that it automatically created the different positions for that particular part itself. This is all being held in one Mac. It knew to automatically create the different hole positions for all of the holes. Since it can be done, all of these can be done in that one particular Mac position. Okay, let's actually run my simulation now. This time when I run my simulation, excuse me, I'm going to use the option of machine simulation. I actually did some homework and I actually created the machine simulation so we can actually use it over here itself. Okay, you can see the part sitting on a machine. Let me actually zoom up a little more. And let's see what happens, how it starts working. You'll note that it's actually going into those holes, actually milling out those holes over there. That's the way this technology was built, to mill out the holes. You see it's milling out all of those holes. It's going to continue drilling. Now it's going to the other side as well. Let me slow it down just a bit so you can see it's actually drilling out all of the holes over there as well. For all of the different positions, you can see all of the operations were created over there, and it's going to work on the entire part, going from the very beginning to the end, including, let it get there. You see you have those holes over there as well. Okay. Going back to over there again, including the ones that are on the angle over here as well. All of them were picked out inside the hole recognition. Again, since all of them can be done in this one Mac position, in this one Mac. And the positions were created automatically. Today's actually webinar is, like I said, recovering these areas over here. Now, as far as building, now let me just actually be straight out forward as much as I can with the automatic hole recognition and machining, is that we've actually had this for several years already. However, it never really worked properly. It was always asking you for different tools. It was always asking you for, and if you used it, it gave you all different types of problems. What we've done is we have it now working where it actually recognizes all the different types of tools that you may want to use. And this is only the beginning. Over the next year, we'll actually be making a lot more improvements inside automatic hole recognition. One of the improvements, for example, is as far as using this, that if I were to go and, excuse me, if I were to go into my hole recognition, now if you remember correctly, when I did the hole recognition, what happened? I had to go through step 1, 2, 3, 4, 5, and that actually, even though it was a very quick process of clicking through all of them, but I had to do that. What we'll be adding over here is, if I open this, I can go directly over here, and it'll automatically do all of them in one shot without me having to click all of these options over here. This will still be here in case you want to go in, if you want, because at any step, if you want, you can actually change the shape type if you want. There's all different types of things that you will be able to do in the interim. You can make ones that you don't want to machine, for example. However, if I leave everything the way it is, I can just click a button at the very end. I'll be having that, and you'll be able to calculate everything, do the entire operation very quickly, including different feature sets, like I did before, where if I had 4 different feature sets, I had to go back to feature sets and change the feature set I was working. That will also be made automatically within the next year as well. Those are improvements that we're always having. Again, if there are improvements in general, by the way, if there are improvements that you'd always like to see in the program itself, contact your local reseller or your SolidCAM representative, bring in your request to him, and it'll always be forwarded. You can always write also to webinar@solidcam.com, and they will also come into us over here as well, and any single suggestion is always looked at. As I said, all the improvements that are made in the program, many of them come from suggestions that are from customers themselves. Okay, that's basically it for today's webinar. Let me see if there are any questions. Hold on. Is these operations useful also with SolidWorks standards? If you're talking about recognizing SolidWorks standards, I would imagine yes. I'm not sure. Yeah, definitely. Okay, when using the multi-axis hole recognition module, does the top of the hole have to be perpendicular to the hole axis? No, it does not. It does not have to be perpendicular to the hole axis. It'll pick those up as well. It picks up every single hole, and it'll create a position for that hole as well. The feature, okay. It is not, however, it is not aware. Now remember, these are 2.5D operations. In any case, these are still 2.5D operations. It is not aware of the stock conditions. Okay, a good question here was also, if 2 holes cross each other, the hole recognition recognizes the continuation of a hole through the next hole, and it will see that as one hole going through, and the same thing with the hole coming from the other side as well. So it'll recognize still the entire hole in its entirety. The multi-axis module creates a new MAC for each index. No, it actually created a new position. What it did automatically, it created a new position, not a new MAC. Can it create a new MAC? That's not the way it works right now, but I mean, I'll check into that. This, like I said, this is specifically a 2.5D operation for drilling, for holes, okay? This is not a 3D recognition. This is specifically for automatic hole recognition and machining. So it's not a 3D operation at all. Next week, we will be showing you, by the way, like I said, we'll be showing you how SolidCAM recognizes in SolidWorks the whole wizard of SolidWorks itself, getting all of the options that are in, recognizing all of the information of the SolidWorks whole wizard, and showing you how we actually use it. That's in next week's webinar. Okay, as every week, my webinars are recorded, and tomorrow they will be available on our site, together with the parts itself. So if you want, you can always go and practice and with the recording and the parts itself. Okay, everyone. I'd like to thank everyone for joining the webinar. See you in our next webinar, and have a fantastic weekend.